using Laplace transform. Okay, but the second group, solving equations using Laplace transform or the Laplace transform. Laplace transform. Okay, that's it. So this is it, the first one. The first one, this first one is part of the one that we started the other night, but we were not able to finish it because if that differential equation would have a repeated solution, you cannot use the previous method that we talked about it. You have to do the translation method. So that's why I start with this one, and this is a popular case. So this is it. It's a y double prime. Okay, y double prime minus 4y prime. You want to solve this. Plus 4y equal to the 0. Okay, solve this equation. Initial condition is y of 0 equal to 1. And the y prime of 0 equal to 1. Okay, this would be new if you compare it with what we did. So as usual, change it and take the Laplace transform solution. So suppose your solution is of the form of y equal to the f of t. Okay, is the solution is going to be the solution with the initial condition that is given. The initial condition is f of 0 is equal to 1 and f prime of 0 is equal to 1. Okay, take the Laplace transform on both sides and continue. So this is going to be Laplace of f double prime of t, the first one, minus 4 Laplace of f prime of t, okay, plus 4 Laplace of f of t is equal to the Laplace of the 0. The Laplace of the 0 is 0. That's a step one. Step two, you know that. Change those derivatives. Laplace of the derivatives. So this is f double prime. So you start with the s squared Laplace of, okay, s f of t. Remember the formula minus s f of 0 minus f prime of 0. That is the Laplace of the f double prime. Okay. This is going to be minus 4 times the Laplace of the f prime. So it's going to be s, okay, s times Laplace of f of t minus f of 0. That's the Laplace of the f prime of t. And then you have 4 Laplace of f of t equal to the 0. Apply the initial condition and simplify it. You can, you can multiply this one and at the same time get those initial conditions. So the initial conditions are f of 0 equal to 1 and f prime of 0 equal to 1. So the result now is going to be s squared Laplace of f of t, okay, minus, you see this is f of 0. I replace this one by 1, okay, and this one by 1, and this one by 1. So it's going to be s squared Laplace of f of t minus s, okay, minus 1. You multiply this one inside, it's going to be 4 times 4s times the Laplace of f of t. And we have a negative 1 over here, okay, times negative 4, so that you have positive 4. And then we get the 4 Laplace of f of t equal to the 0. Okay, I distribute it and I substitute the initial condition. So put them together. You have, as usual, you have to factor out the Laplace of f of t. So if you factor out, that give you s squared minus 4s plus 4. This is what you expected, because that's the characteristic equation of the given equation. okay, homogeneous one, and times f of t. So the leftover is going to be minus s. It's a negative 1 and a plus 4, which make it with a positive 3. Okay, so that will be positive 3 equal to the 0. You move it to the other side. So s squared minus 4s plus 4, Laplace of f of t is going to be s minus 3. So you solve for the Laplace of f of t. Okay, so that would give us a Laplace of f of t is going to be equal to the s minus 3 on the top, and that gives s squared minus 4s plus 4. Okay, so now the Laplace of f of t, then you have to get the Laplace inverse. So f of t, the solution is going to be Laplace inverse of s minus 3. You see the denominator is factorable. You factor it, it's going to be s minus 2 all squared. So you have to find the Laplace transform of this new function. Okay, s minus 3 over s minus 2 squared. You can break it into 2 parts, and then you come back and you talk about it. A different way to do it. You can write s minus 3 as s minus 2 minus 1, easily break it, or you can use the partial fraction. Okay, so that would be easier to do it. As you see, you have 2 choices, s minus 3 over s minus 2 squared. So what I do, I write this one as s minus 2, and that would be minus 1. Then I have s minus 2 squared. So I break it. That give me s minus 2 over s minus 2, okay, all squared. Okay, that is going to be the case. Okay, s minus 2 over s minus 2 squared minus 1 over s minus 2 squared. That is going to be the case. Okay, now we can simplify. We can simplify the s minus 2, one of the factor. You cancel it out. You see if you cancel 1 out, then you can handle the rest. So this is going to be equal to 1 over s minus 2, and this is going to be 1 over s minus 2 all squared. Okay. Now we can do the first one, which is e to the 2t. Okay, and the second one, you can use the translation to do it. It's s minus 2, you can call it s. So it's going to be 1 over s squared. Okay, 1 over s squared is what? Is the Laplace of t. Okay, and because you have the t's translation, then you have to multiply by what? E to the at, which is going to be e to the 2t, and then you're done. So now we have these, okay, facilities to do it. Okay, so there you are. So the Laplace inverse of s minus 3, okay, s minus 3 over s minus 2 squared is going to be equal to the Laplace inverse of the first one, 1 over s minus 2 minus the Laplace inverse of the second one, s minus 2 all squared. Okay, so the first one is just e to the 2t. That is going to be the first one. Okay, and for the second one, this is it. Again, we talk about it, we take it as a translation. If you take it as 1 over s squared, so you get the t. But you have to multiply, remember, you have to multiply by the e to the at over here. So this is going to be a is 2. So it's going to be e to the, okay, e to the 2t. E to the 2t, and you're done. Okay, so f of t is equal to the e to the 2t minus t e to the 2t, the final answer. Okay, so the new thing is that part. Remember when I proposed this one the other night, we want to do it, I stopped because I didn't have these tools. Because we cannot do anything about s minus 2 squared. Okay, so what we did over here is the Laplace of, you see, I explain it. You see the Laplace of t is going to be 1 over s squared. 1 over s squared. If you change the s into the s minus a, remember, if you change the s into the s minus a, then you have to multiply. You see that give you t e to the at is going to be 1 over s minus a squared. That is the second translation theorem. So what we did over here is exactly the same thing. So I call s minus 2 just s. So I got the t, but I have to pay for it. E to the at, which is t e to the at, the final answer. Okay, any question? So this is the way we are going to handle the repeated factors. Yes. It's not possible. You see that a square is not possible. When you have a repeated factor, you see you have s minus 2 squared. You can't do anything about it. You need that translation to be able to do it. Because you don't have any choice for this one. So that theorem would take care of repeated factor, would help us quite a lot for this number. If you go back now to one that we did the other night, then you'll be able to continue. But you need one more thing to be able to do it. And that is the, okay, that's the one that we have for the completing the square. I bring it back. It takes time. Otherwise, I bring it back, to give you these numbers again. Okay. So you will see from now on number of the problems, especially that to take a repeated factor. So we have one more in your practice one, y double prime minus 2y prime. Okay, and plus 4 again, repeated factor. So we take care of it. Okay. So this one was nice. Otherwise, that lacking calculus 2, you can break it. If you have repeated factor, you can put the a on the top, a over s minus 2 minus b over s minus 2 squared, and use the method of the partial fraction to be able to take care of it. But that was, nicely designed, so we didn't have any difficulty. Any question? So this is the new version that we're going to have. So when you get your practice test, then we can bring this type of equation as well. So we have more opportunity to have more equations. So this is one that we have to do. The other one is if the equation would be a kind of non-homogeneous, but you get a number of those functions. Okay, you need the step function. Yes.
I forgot. Did we go over the case of s minus a type functions with like trigonometric functions and stuff like that? Yeah, we only done it with. Like, is there a different case, like a different theorem to use?
Yes.
Okay.
Yes, quite a lot. One is here now. Okay, this is. Let me just give you the next one. Yeah, all of them. Now you are able to solve all the problems. Okay, all the differential equations that you have. This will take care of the repeated factors. Now the next one would be if you have a number of the unit step function. How can to handle those? So this is the second one. The second one, you get to solve this equation. The equation is y double prime plus 4y is equal to the, look at this one, is a sine t minus u2 pi t, u2 pi t, the sine of, the sine of t minus 2 pi, t minus 2 pi. This is the equation. And your initial conditions are going to be y of 0 is equal to the 0. And the y prime of 0 is equal to the 0. Like the one that you did on the quiz, it was just a single function. Okay, u10t. So let's set up this one to see what's going to be how we're going to find that Laplace transform. Okay, are you ready? Take the function and continue. Solution. You are going to suppose your solution is f of t, y equal to the f of t is the solution. Okay, is going to be the solution with the initial condition that is given. Okay, with f of 0 is equal to the 0, and f prime of 0 is also equal to the 0. Okay, now to take the Laplace transform on both sides and continue. So what's going to be the result? We have f double, y double prime. So it's going to be Laplace of f double prime of t. Okay, plus 4 Laplace of, okay, Laplace of f of t. And now on the other side, we have to take the Laplace transform of this function too. Okay, it's going to be Laplace transform of the sine t, the first part, minus Laplace of the function u2 pi t sine of the, okay, sine of the t minus 2 pi. Which nicely would be given to you so that you'll be able to apply the theorem. Now substitute for those prime, f double prime. So it's going to be s squared Laplace of f of t. Okay, s squared Laplace of f of t minus s f of 0 minus f prime of 0. Start with s squared. We don't have anything else, so it's going to be just plus 4 Laplace of f of t. You go to the other side and you find the Laplace of those functions. The Laplace of t. What's the Laplace of t? Laplace of sine t. 1 over s squared plus 1. Very good. Minus the second one. That's the translation. Okay. This is it. Because of the u2 pi t, we have a coefficient of e to the negative 2 pi s, not divided by s. That's e to the, remember, it's e to the cs, e to the negative cs, Laplace of f of t, if you like. So a Laplace of, the function is sine t. Sine t, and the Laplace of the sine t is going to be 1 over s squared plus 1. Okay, because it's nicely designed, and just this is the way we're going to do it. Any question? We'll just use that theorem that Laplace of the UCT f of t minus c is simply e to the negative cs Laplace of f of t. Okay, so apply the initial condition. So the initial condition that we have are nice, f of 0 equal to the 0 and f prime of 0 equal to the 0. So nicely, this would disappear and this would disappear. So the leftover is going to be what? You factor out the Laplace of f of t. So that gives you s squared plus 4. S squared plus 4 Laplace of f of t. Nothing else here. Everything would cancel out. But on the other side, you are going to have 1 over s squared plus 1 minus e to the negative 2 pi s. Okay, 2 pi s over s squared plus 1. This is what we got on the other side. Now you divide by s squared plus 4. You divide them 1 by 1. Okay, so the Laplace of f of t is going to be equal to, if you divide the first one, so that give you s squared plus 4 times s squared plus 1. That's the first one. And if you do the second one, it's e to the negative 2 pi s. Again, you get s squared plus 1 times s squared plus 4. That's it. So your solution is going to be f of t equal to the Laplace inverse of the first one. Okay, Laplace inverse of the first one And if you find the first one, quickly you can do the second one. Okay, minus the Laplace inverse of the second one. E to the negative pi s, s squared plus 1 times s squared plus 4. See, that's the one. So if you find the Laplace inverse of the first one, you see the inside one, that function would be f of t. We can use it here. We can use it here because you have that, okay, that coefficient will tell you that it's going to be, you have a translation of it to be able to do it. So if you find this one, call it f of t. The second one easily would be what? Easily is going to be u2 pi t, u2 pi t f of t minus 2 pi of the first one that you have. So you have to find the Laplace inverse of this one, which is easy. Just partial fraction, break it, easily can be done it as a shortcut. Okay, so there you are. 1 over s squared plus 4 times s squared plus 1. We're going to talk about how we're going to do it. This is going to be s squared plus 4. And you write minus s squared plus 1 because you want to cancel out the s's. Then you check to see if you are going to be off something. If you check it, what's going to be the result? It's going to be s squared plus 1 minus s squared minus 4. S squared and s squared will cancel out. What's going to be the leftover? You see, the top would be what? The top would be s squared plus 1 minus s squared minus 4. So these two would cancel out. You get negative 3. And you need 1 here. So what you need to do, you change this 1 into there. You divide by negative 3. So it's going to be 1 over negative 3 and 1 over negative 3. So this is how we're going to do it. Okay. So I'm going to have a negative 1/3 s squared plus 4 and a positive 1/3 s squared plus 1. Okay, that's the way quickly you can, you can take care of it. You are not going to write it down, if you want to do it as, partial fractions, you have to put something like, that a1s plus a2 on the top. No, we don't do it for this type of ideas because the top is just a constant. Okay, any question? Now we can find the Laplace transform of this one. Laplace inverse right away. So what's going to be Laplace inverse of this? So the Laplace inverse of 1 over s squared plus 4 times it by s squared plus 1 is going to be equal to, both of them are going to be sine. Okay, so for the first one, you pull out the negative 1/3, but you have to pay for it for the sine because this is s squared plus 4. So you need a 2 on the top. You can arrange it. You see, you can do it right away, really, at this time. So that's s squared plus 4. And that would be 1/3 Laplace inverse of 1 over s squared plus 1. So for the first part, you need a 2 on the top. So we can create that 2 on the top by dividing the outside by 2. So it's going to be negative 1/3. Okay, 1/2. So it's going to be Laplace inverse of 2 over s squared plus 4. That gives you sine of the 2t. For the second one, we don't need it. This is 1/3 of the sine of the t. Okay, so the final answer would be, you get negative 1/6. Negative 1/6 sine of the 2t plus 1/2 sine of the t. So this would be the Laplace inverse of the first one. You call it g of t, then you get the second one right away. What's that?
1/3 times t.
Why is 1/3? Oh, that's 1. Oh, yeah, that's it. Thank you. That's it there. Okay. So you can call this one if you like. If you don't like to repeat it, you may call it g of t. Quickly get the second one. So what's going to be the second one now? So the Laplace inverse of the second one, e to the negative 2 pi s over s squared plus 1 times s squared plus 4. You see, if you forget about the e, it is what? It's g of t. But since you have this translation, it's going to be u of 2 pi t, u of 2 pi t, g of t minus 2 pi. Okay, because you get this translation of the 2 pi, so you have to change the function from the t into the t minus 2 pi. So the final answer, remember you are looking for f of t. So the final answer would be f of t equal to, remember this is your f of t. So your f of t is going to be g of t minus u 2 pi t, g of t minus 2 pi. And you have to introduce the g. So this is going to be the case where what is your g of t? G of t is negative 1/6 sine of the 2t plus 1/3 sine of the t, unless you want to list all of them. Okay, this is the way we do it. Okay. Otherwise, you can, you can write all of them, all together. Yes. This one? U2 pi. Okay, so the final answer would be, briefly write it down in this form. These problems are designed so that, they're going to be connected to each other. Anytime you have you need the step function, it's going to be the case. There's going to be one portion that you find that function, and then quickly the second part is going to be related. So that's why you are not going to, you see, when you divide, you leave it as is, okay, as the parts. If you find the common denominator, put them together, you will lose everything. Okay, and you make it complicated. Yes.
So in the future, if we have a similar case where we have a 1 over something and e to the negative cs over something, and the bottoms are both the same.
It's the case, yeah. It would be the case all the time. You see, this is the nature of this equation. So you don't have to get the second one. They are coming together, okay? Coming together all the time. Okay, so that gives you an experience how we're going to handle this unit step function type, okay, for this case. Any question? So I give another one, the one that you like, the one that we tried the other night. We show you that you've got to be very patient and to take care of it. It's going to be the next one. Any question? So what is going to be the third one? The third one, I can do the one that we did the other night, but I'll give you a new one. This is it. You have y double prime minus 2y prime plus 2y. Okay, like the other night, it's e to the negative t. We want to solve this equation. Y double prime minus 2y prime plus 2y equal to the e to the negative t with the initial condition of y of 0 equal to the 0, y prime of 0 is equal to 1. Let's see what would happen to this one when you get. You see, if you work on the characteristic equation, it's going to be s squared minus 2s plus 2, and this is not factorable. So that's why you have to use the completing the square method. I just wanted to see how we're going to handle in this type of problems, okay? And there you are. So let's do it. Solution. Take the function again, work out on these terms carefully. So again, we suppose we have the solution. Suppose y equal to the f of t, okay? F of t is the solution with your initial condition. What is initial condition? F of 0 equal to the 0, okay? And f prime of 0 equal to 1. So I change it into this notation. Carefully take the Laplace transform on both sides. Okay. So there you are. You're going to have a Laplace of the f double prime of t, the first one, minus 2, Laplace of f prime of t, plus 2, Laplace of f of t, and on the other side, Laplace of e to the negative t. Okay. Now start changing those Laplace of the derivative of the functions. F double prime, F prime, you have all of them. Okay, carefully substitute. The first one would be s squared Laplace of f of t minus s f of 0 minus f prime of 0. That's the first one. Then go for the f prime. Minus 2 times s Laplace of f of t minus f of 0. That is the f prime part. And you come back to the f Laplace of f of t equal to, what's the Laplace of e to negative t? 1 over s plus 1. S plus 1. Apply the initial condition to simplify. What's the initial condition? You have f of 0 equal to the 0, f prime of 0 equal to 1, which means f of 0 is 0, so this would disappear. Okay, that would be 0. But f prime of 0 is 1, so this would be 1. Go back, rewrite it. So this is going to be, we have the s squared Laplace of f of t. Okay, we have a negative 1 here, or minus 1. Then you multiply the 2 inside, minus 2s Laplace of f of t. Okay, this is 0 and plus 2 Laplace of f of t equal to the 1 over s plus 1. Factor out the Laplace of f of t and double check it that you get that characteristic equation. Okay, so there are 1, 2, 3. So that gives us s squared minus 2s plus 2 as we expected. Okay, and the Laplace of f of t. What's going to be the leftover? The leftover is just a negative 1 here. I move it to the other side. Is 1 over s plus 1 plus 1. Okay. Now you divide both sides by s squared minus 2s plus 2 and then take the Laplace inverse. So it's going to be Laplace of f of t equal to, when you divide it, you do it 1 by 1. So it's going to be equal to what? 1 over s plus 1 times s squared minus 2s plus 2. That's the first one. Plus 1 over s squared minus 2s plus 2. Okay? So you have to find the Laplace inverse of these two terms. So your f of t is going to be equal to the Laplace inverse of the first one, or both of them together. Laplace inverse of the 1 over s plus 1 times s squared minus 2s plus 2. Okay, and the other one. You can do it now or just break it later on, or you can do it. Laplace inverse of 1 over s squared minus 2s plus 2. That's it. Okay, the second one is easy. It's not factorable, but we can use the completing the square method, take care of it. Okay, let's do it, or you can leave it and do it later on. Let's do it first, just to remind you what are going to be involved with this problem. This is the idea of the point about this problem. So we have the s squared minus 2s plus 2. Remember the way we're going to make it complete the square? We divide the coefficient of s by 2 You see, divide this one by 2, and you make it as s minus 1 all squared. But when you square it, that gives s squared minus twice times per second, okay? So we have to, you over 1 squared, which is 1. Okay, s minus 1 squared minus b squared, we call it. And the other number, the leftover is 2. So this is the way you're going to make this complete square. Yes.
Would you be able to do the complete square thing before you divide everything and make it easier? Personally, it's easier to break it up if you completed the square before you divided everything like that.
You can't divide this one because the denominator is not factorable. You mean before dividing by this? What do you mean?
Yeah, you complete the square first and then divide it through. Like when it's,
No,
no?
no. You better keep it as is. Because you do the complete square when you need it. Okay, otherwise it would be complicated. Because you are not going to touch the first one. Because for the first one, you have to do the partial fractions. So if you do the complete square over there, you know, you'll be so confused. No, we just do the complete square when you need it. It's a single term, complete square, okay? So you will see it in a minute. I'll come back to that. Even I could have waited for this one because there is going to be a factor of the first one. I can combine them together. But I just do this one, you know, to get rid of it. So this is going to be Laplace inverse of what? You get 1 s minus 1 squared plus 1. You see? Nice. It's ready for the translation. It's s minus 1. You call it s. So that you 1 over s squared plus 1, which is sine. Then you pay for it. You multiply by what? This is s to s minus a. You have to multiply by e to the at, which is e to the t. Okay, so this is going to be equal to, is equal to the translation one, give you e to the t as a factor. Okay, and the rest is what? The rest is just a sine of t. Okay, so this is going to be the first part that we're going to have. Okay, so the Laplace inverse of 1 over s squared plus 1 would be the sine of the t, and you change the s into the s minus 1, so you have to multiply by e to the t. So that's the first part. Laplace inverse of the 1 over s squared minus 2s plus 2. Any question? Now get back to the first part. For the first part, you have no choice. You have to do the partial fractions. Yes. You see the formula that we talk about it? The formula is if you have f of s, if you change the s into the s minus a, on the other side, you multiply the function by e to the at. So in this case, your a is 1. Okay, 1 over s squared plus 1. You see, this is the formula that we use. Laplace of e to the at. F of t is f of s minus a. You see, that's the translation formula that we have. So what we did over here, you see that's a sign. We change the s in the sign into the s minus 1. So you have to multiply the sign by e to the at. A is equal to 1. Okay, question, but we are not done. Go back. The big one is how we're going to find the Laplace inverse of the first part. In order to do it, you have to do the partial fractions. Okay, you have no other choice or other way to do it. So for the rest of the problem, you have to work on this one. So how are we going to find the Laplace inverse of 1 over s plus 1 times s squared minus 2s plus 2? Okay, since the second one, unfortunately, is not factorable, so you have to do the partial fraction. You know, it's nice, we can do it. This is it, 1 over, that is s plus 1, yes? So that's going 1 over s plus 1 times s squared minus 2s plus 2 is going to be s plus 1. It's a linear, so I put the a1 on the top, plus s squared minus 2s plus 2 is a quadratic. You have to put something like A2S plus A3. Okay, some people they call it ABC, it doesn't matter. Okay, so you have to work to get this A1, A2, and A3. So find the common denominator, continue. So the common denominator would be what? Would be S plus 1 times S squared minus 2S plus 2. The top would be A1 times S squared minus 2S plus 2 plus S plus 1 times A2S plus A3. Now you let the top to be equal to each other and then find the A1, A2, and A3. Like, you know, this integral like in calculus 2. So this is it. The top would be A1 S squared minus 2S plus 2. And this is going to be plus S plus 1 times A2S plus A3 equal to the 0. Okay, you can multiply together and put the coefficient to equal to each other. But since you have one solution, you see S plus 1. One nice numbers. You put S equal to -1, that give you one of the variable. Then you need two more numbers. You can pick easy number. One of the number must be 0, and the other one as you wish. Okay, so it's equal to the 1, the other side. So pick the numbers. S equal to the -1. If you put X equal to -1, this is going to be A1 times it by -1 squared would be 1. -2 times -1 would be a positive 2. Okay, a positive 2 and a 2 again. Okay, and the rest are going to be 0 because you put S equal to -1. And this is going to be equal to 1. Okay, so I just substitute on both sides S equal to the -1 so that you have positive 1, negative, positive. So what are going to have? 5A1 equal to 1. So A1 would be 1/5. That is the A1. Any question? Yes.
Sorry, I forget. How do you get the? Oh, never mind. I see it.
Okay. Now we need two more nice numbers. One of them must be 0. Quickly we get the second coefficients. S equal to the 0. So substitute 0 on both sides. What are you going to get? You get the A1. If you put S equal to the 0, that give you 2. If you put X equal to the 0, that give you 1. Okay, 1 times this would be 0 plus A3 equal to 1. So that will give you 2A1 plus A3 equal to 1. You already got the A1. A1 is 1/5. You see the A1 is 1/5, substitute. So the A1 is a 5th. So if you substitute the A1 here, so that give you what? That give you 2/5 plus A3 equal to 1. So A3 would be 1 minus 2/5, which is equal to the 3/5. So A3 would be 3/5. Okay, any question? You need one more number. You get this one done, okay? I've seen some people, some of you just use the metrics, you know, to solve this system of equation. That would be too much, but you can do it if you like. Okay, we don't mind. Use you know, but these are very routine problems, you know, it's easier. Okay, you need one more number. Pick a number. Yes, what's the question?
Where's the E2?
What is that?
Where's the E2?
I don't know. We have to find it.
Oh,
That's why we are looking for the state number.
S equal to 1.
Okay, S equal to number 1.
Yeah.
Okay, take S equal to 1. You can S equal to 10,000, okay? Or 9.9. Okay, let's take A equal to 1 to get the, okay, to get the A2. It's always the case. I know you are going to be short of the numbers. Okay, any question? I have to go to the next page and put A equal to S equal to 1. So what's going to be the result? Then you put equal to 1. You see over here, let's just do it in the second page. Any question? So not bad, you know, we can do it quickly. So the third number, S equal to 1. Substitute on both sides. So I think the first one was this one. So that give you what? 1 minus 2 plus 2. Okay, plus 1 plus 1. Substitute S equal to 1 wherever you see it. And that's A2 plus A3 equal to 1. Okay. Simplify. So that give you A1 plus that will give you a 2 here, 2A2, 2A3 equal to 1. Yes.
Would you also be able to solve it by
No.
matching like coefficients together?
Yeah. That's another. But then there is one solution that's easier. Okay, because you think about it. You see, always if you take S equal to the 0, you will get one of them. Okay, if you have another number, so that would give you the second one. So then you have to do it now. Otherwise, yes. If you have no other choice, okay, if you don't have any linear factor, we go for it.
If I just like multiply everything.
Yeah.
And then draw everything down.
That's it. Yes.
Since there's only a constant S squared in the.
Yes. You can do that one. Okay. So let's finish it. What was the A1? 1 over 5. A3, 3 over 5. So the A2 is missing. So, you know, it depends on the problem, the nature of the problem. So this is it, a fifth, 2A2. And this is going to be 2 times 3 over 5 equal to 1. Okay, so that gives you a fifth, 2A2, 6/5 equal to 1. So 2A2 is equal to the 1 minus a fifth and the 6/5. Okay, minus. Okay. I just checked to see if you're following me. Okay, 2A2 is equal to the what? 1 minus a 7/5. That gives you negative 2/5. Okay, you divide by 2. A2 would be negative 1/5. There you are. Go back, substitute to see what you get to be able to continue now. Okay, so let's going back. They change it into this form that we have. So that is it. This is 1 over S plus 1 times S squared minus 2S plus 2. That's the original one. Okay, so we put the S plus 1 with the A1, which is a fifth. Okay, plus we get the S squared minus 2S plus 2. Now on the top, A2S, 1/5 of S plus A3. What is the A3? 3/5. You see, you have to work on the Laplace transform of this function now. To get it true, Laplace inverse. The first one is easy, it can be done. The second one is the one that you have to organize it because the number is not factorable. So the best thing you can do for the second part is take this fifth out. You see that's a 1/5, 3/5. We can put out all the 1/5, make it easier to handle. Okay, so that give you 1 over S plus 1, and this is going to be plus. Okay, it's a negative S plus 1. So I'm going to take out the negative here. So I write is as S minus 3 over S squared minus 2S plus 2. You see, this is going to be the case. Again, remember the bottom one is not factorable. So you have to make it completely square and arrange the top accordingly to be able to do it. So it's going to be equal to a fifth. We can handle the first one. S plus 1. Now the top. So completing the square, we already done this one. Is what? S minus 1 all squared. Remember, it was a plus 1. And on the top, we get S minus 3. That's it. You have the S on the top, so you have to use the translation for the cosine. This is S minus 1. You need to have S minus 1 on the top as well, so that we'll be able to take care of it by the cosine. So it's going to be a fifth. Okay, 1 over S plus 1 minus, do as we did for the other problem. I'm going to make this one into the S minus 1. S minus 1 minus 2, because that's a negative 3. Okay, now break it. It's going to be 1 over S plus 1 minus S minus 1. S minus 1 all square plus 1 plus 2 over S minus 1 all square plus 1. You see? Now it's ready to be taken care of. So it's unavoidable when you get it, this non-factorable one, always you end up. Now we are ready to find the Laplace inverse of this part. Okay, remember we are looking for the Laplace inverse of 1 over S plus 1 times it by S squared minus 2S plus 2 is going to be equal to the fifth. Laplace inverse of 1 over S plus 1. What is this one? Laplace inverse of 1 over S plus 1, e to the negative t. That's the first one. Second one, yes.
The third thing would be negative.
There is a negative here. So negative would be plus.
One is S minus 1.
Okay, because a negative. Now this one, if you call S minus 1, S is S over S squared plus 1, which is sine. And you have a translation, so we have to multiply by e to the t. So it's going to be minus e to the t sine of the, cosine. Cosine of the t. Okay, S over S squared plus 1 is cosine of the t. You translate it. You change the S into the S minus 1. You pay for it. E to the at. Next. This is going to be plus 2. You call S minus 1 S, so that would be cosine. Sorry, that would be sine. Sine of t, but the translation, so it's e to the t. Okay, e to the t, sine of the t. That's it. Okay, multiply a fifth inside. So e to the negative t minus 1/5 e to the negative t cosine of the t plus 2/5. Okay, 2/5 e to the t sine of the t. This is the Laplace transform of the. Remember, there was another term that because there was a two terms, then we want to find f of t. So we go back, we combine them together, and you have the final answer. So what's the final answer? F of t is equal to, remember, look at this. There was a leftover over here that we did take care of it, e to the t sine t. So you add these together and simplify it. So that would be a fifth. Okay, that would be a fifth e to the negative t minus fifth e to the t cosine of the t plus 2/5 e to the t sine of the t and e to the t sine of t. Yes, then you have a 2/5 and a 1. Yes, we simplify these two. So that gives you 7/5. You are right.
What do you need to simplify this?
Of course. Yeah, you have to combine the like terms.
Well,
Yeah.
minus 2/5 is very difficult when you're on an exam, you know?
You have to combine like that. Okay, that's right. So it's a fifth. No, I said if you need a common denominator, don't do it. Remember? This is the only one that you do it. Otherwise, it's just part of the thing. You have to combine the right things. Okay, e to the t. Besides, you've been spending 15 minutes to do this one. We'll just spend 1 more minute to simplify. Okay, so it's going to be 7/5 e to the t sine t. Okay, so kind of the longest one, you know, when we get these equations. And it's part of the deal. They arrange it so that one side would be a non-factorable equation. Okay, that's one. So it can be done. And that's it. These are all the various parts. I give you a break. Then we come back and we do the same thing, but this time we do it to the system of the equations. Okay, so we are done. You should be able to solve any differential equation, linear differential equation using Laplace transform. Okay, that's fine. So let's have 10 minutes, then we do the second.
Yeah, I honestly looked at it, so I'm kind of, I don't know, what did you get? What'd you get?